All right. So we are given this parallelogram ABCD in which this highlighted portion BP and BQ are given to be equal. Then we need to prove following 5 points. Prashant, you may read 5 points one by one.
Yes. Triangle APD is congruent to triangle CQB.
Triangle ABD is congruent to triangle
CQB.
CQB. This is APD, sorry, is congruent to triangle CQB. Part 2 says
AP is equal to CQ.
Okay. We will do in parts. Let's pause here and discuss these two parts first. Okay? All right. So in triangle APD and CQB, children, if we prove first part, will the second part follow automatically?
Yes, ma'am.
By CPCT. If we prove first part, second part will be done by CPCT. So let us focus on part 1. So part 1 is we have to consider two triangles in triangle APD and triangle CQB. Let us look out for 3 conditions. Let us first of all trace these triangles APD. APD. Because this triangle, children.
Yes, ma'am.
In these two triangles, something is highlighted.
Yes, ma'am. Ma'am, BQ is equal to PD.
BQ is equal to PD. This is given to us.
Yes, ma'am.
All right. Something else is also given. That ABCD is a parallelogram.
Ma'am, so
BC
AD
is equal to
BC.
AD.
Yes. AD
is equal to BC.
Opposite sides of a parallelogram. Now, what else, beta?
Angle B is equal to angle D.
We have got these two. Now, we can't say angle B because angle B would mean the complete angle B. We are just focusing on the part, this part, right? We are just focusing on this part. So, if we are focusing on this part,
Angle QBC.
Simultaneous interior angle.
Yes. And children, just keep in mind, whenever we are saying alternate interior angles are equal, we must mention which sides are parallel. So here, which sides are parallel?
Ma'am, AD and
is
BC.
parallel to BC.
AD and BC.
Parallel to BC because it's a parallelogram. All right, beta. So we have to write these 3 pieces, keeping in mind the parts of this triangle should be written below this. Parts of this triangle should be written below this, and the reason would be coming in the corner. So let us just write down APD. APD, we are given DP. This DP. So if we are moving from D to P, we should move from B to Q. Order has to be maintained. DP is equal to DQ. Reason?
Given.
Now APD, the name of the angle is 2. Be careful. We are in the habit of writing 1 equal to 2, but 2 is here, the part of APD. Reason?
Alternate interior angles.
Angles as
AD
AD
is parallel to BC.
Right? Then we need to write AD, first to third, AD. So C to B, first to third. And order has to be maintained at anyhow. So AD is equal to CB, opposite side
parallelogram are equal.
of parallelogram ABCD. All right. So therefore, triangle APD is congruent to triangle CQB by side, angle side, and this gives me AP equal CQ. CP, CP. Clear, children?
Yes, ma'am.
We will write this proofs 1 and 2. Now, what does it mean? It means that we are writing that first two parts are proved. Okay? Yes, children. Now we have to show that AQB is congruent to CPD. AQB, if I just trace, it is going to be this triangle. AQB and CPD, right? So now I have to take care of these two triangles and need to prove them to be congruent.
Congruent.
Let us see which conditions we have with us. I'm just zooming a bit so that we can see carefully. Which conditions we have in these two triangles? Keeping in mind ABCD is a parallelogram.
Ma'am, AB equals to CD.
Yes. AB is equal CD. Opposite
CD.
side of
Parallelogram.
parallelogram. Then BQ is already equal to
DP.
Ma'am, given.
Let me just mark this angle as 3 and this angle as 4. And can you see
Ma'am, alternate interior angles.
alternate interior angles as these two lines are parallel?
Ma'am, as
being
AB
opposite
parallel
sides
to
of-
CD.
Yes. So are these two triangles congruent, children?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Two triangles are congruent. By CP, CP will be definitely get AQ is equal to CP.
Yes, ma'am.
Yes. Then we have to show that this APCQ is a parallelogram. APCQ is a parallelogram. Now here, children, if you see, we are showing that AQ is equal to CP, part 4. In part 2, we have shown that AP is equal to CQ. Yes or
ma'am.
no?
Yes, ma'am.
Now, APCQ is a quadrilateral in which both the pairs of opposite sides are equal.
Yes, ma'am. Yes, ma'am.
And a quadrilateral in which both the pairs of opposite sides are equal is called
Parallelogram.
parallelogram. Are you clear?
Yes, ma'am.
Yes. So let us just note down the parts of this triangle below this. AB is equal CD. Angle 3 equal angle 4. And then we have BQ equal DP. Reason here would be opposite sides of parallelogram. Okay. This would be alternate angles as AB parallel BC. And this is given. So therefore, triangle AQB is congruent triangle CPD by side, angle side. And this gives me AQ is equal CP by CPCT. All right. So here we are taking a pause as we have proved two parts. So this proves third and fourth. Okay. Now next we are going to write down the reasons for part 5. We are going to give justification that why APCQ is a parallelogram. Now, from parts 2 and 4, we have AQ is equal CP and AP is equal CQ. That is APCQ is a quadrilateral in which both pairs of opposite sides are equal. Hence, APCQ is a parallelogram. Okay.